in here given a perfect binary tree, and we need to make connections. So we need to point each level's nodes to each other. So in this level, 1 will be pointing to null, 2 will, in this level, 2 will be pointing to 3, 3 will be pointing to null. In this level, 4 will be pointing to 5, 5 will be pointing to 6, 6 will be pointing to 7, 7 will be pointing to null. So, and then another follow-up question that it is asking, solve it in constant extra space. So a naive approach would have been utilizing a data structure, usually Q, because this is breadth first search style of questions, because like we're going level by level, and in there, since we were utilizing a data structure extra space, that approach space complexity would have been O of n. So in this case, in order to make a constant space complexity, we can actually use the given perfect binary tree itself. So what we are going to do is that we will be seeing the leftmost of these nodes. So we will be seeing 1, 2, 4, and whatever comes on the left side. So that's how we can iterate all of them. And then when we are seeing those leftmost nodes, then we have an ability to see the left side of it and right side of it. And from there, we can make a connection. So if we're here, left side is 2, right side is 3. So we're making a connection between 2 and 3. And when we're here, we have an ability to see 4 and 5. And we also have an ability to see if there's a connection here and see this one as well. So let's say we're at number 2, node number 2, and then we're connecting 4 with 5. Then we're checking if there's a connection. Then we're making a bridge between 5 and 6. Then we can actually go over 3 and connect its left with right. So let's say if there were other nodes under here, we would have been connecting 4th left and right, and then jumping on 5, make a bridge between 4 and 5, and then connect 5th left and right, then make a bridge between 5th and 6th, and connecting 6th left and right, etc. So let's jump into coding. First thing first, let's take care of when it becomes null. We'll just simply return null in this case. So leftmost, we will be only seeing the leftmost. Now it is pointing to 1. So while leftmost left not equals to null, we will be seeing 1, 2, and 4. We will be updating. So that's how we are iterating, and then only seeing the left side of it. While we are iterating it, we need to be able to see the current node and then access its left and right. So current leftmost, and since we're seeing the left side and right side, have an ability to see it and connecting them, and also in cases where there's a connection, then we need to jump onto its sibling. So we need to also iterate over the current node. So while current is not equals to null, then we'll be making our iteration. So current equals to current. So like I was saying, so when we can make a connection while we're seeing the current node, we can make a connection with left and right. And then also, since if there is a connection between its sibling, then we have an ability also to make a bridge and jump on that and make a connection with left and right, and we will repeat this process. So first time we're making a connection between left and right. So let's say we're at 2, we're making a connection with 4 and 5. So current left, next we're making a connection, current, and then with it's right. And we need to also check if there was a connection between 2 and 3. If so, then we'll make it's a connection between 5 and 6. So if current dot next not equals to null, then we're making current with right, making a connection with current 3, current next, which is 3 is 6. So next, and that will be the left side of it. So let's run our code. Now we need to return null root. Let's submit it. So time complexity in this one is O of n, where n is all nodes in given perfect binary tree, and space complexity is O of 1 because we're not using extra space.